Okay, fifth graders, we are going to pick up pretty much right where we left off, staring at the same chart that you were supposed to have answered at the end of the last video. And we're going to fill it out, and then we're going to hopefully use the pattern to help us identify what it would be for a decagonal prism. And we crossed off the decagon at the end of the last video, so you could focus on the rectangular prism, the pentagonal prism, and the hexagonal prism. Those were the three that you were responsible for answering, and hopefully you found those to be successful. So the first thing I'm going to do is I'm going to fill in that first column, and that's pretty straightforward, guys. That is simply the number of sides on the base. So we're simply coming up here, and we are looking at this case in a pentagonal prism at the five-sided figure. So all we need to do is say how many sides does this shape have. Well, a rectangle has 4, so I'm going to put for a rectangular prism that it has 4 sides on the base. Pentagonal is 5, hexagonal is 6, and for this one, again, there's no real pattern. It's just simply understanding what the prefix means or what the naming of this is, and a decagon or decagonal prism then is going to have 10 sides on its base. All right? So this is where the patterning starts. This is where we start to identify moving forward. As we look at the triangular one that they gave us there, guys, we are seeing that if a triangular prism has 3 sides on its base, the number of faces goes up to 5. All right, so we are looking directly at that correlation first. Okay, so we're looking at number of faces went up 2 there. Well, if you look back to your rectangular prism, and we've done probably 4 or 5 of them over the course of our videos, guys, and questions you've been asking, you should see that we are always coming up with the number of 6 for a rectangular prism. As we look at that, we have a top and a bottom for 2. Both of those are bases, both of those are faces. And then we have a right and a left and a front and a back. There are always 6 faces in a rectangular prism. So again, we're noticing that the number of sides on the base plus 2 gets us to the number of faces. Now remember, we are dealing with prisms right now. We are dealing with 2 based 3D figures, a top and a bottom. All right, how about the pentagonal prism then? So as we look at the pentagonal prism, it's right here. We can see it at the top of the page. We've got a top or a bottom, whatever you want it to determine to be. The opposite side, top or a bottom for 2. And then from each of the sides, 5-sided figure, going and connecting those 2, we have a face from each of them. So this would be 3, 4, 5, 6, and 7. So again, 2 larger than the number of sides on the base. So hopefully you are starting to identify, guys, now that we have however many sides there are, and those sides are each going to start a face going to the other side of the shape, and then you've got a top and a bottom, which is where our plus 2 comes in. All right, so if we're using that same pattern here, the hexagonal, even though it is right here and we can count them, should end up with 8 faces, a top and a bottom, and because it is a 6-sided figure, 6 faces going from the top to the bottom. Now we do not have a picture of the decagonal, but again, hopefully identifying the pattern, plus 2, plus 2, plus 2, plus 2, that we're going to have enough of a pattern there to establish that we should have 12 faces in a decagonal prism, simply identifying the pattern. All right. Now, number of edges. Again, there is a pattern. If we look at the triangular one that they give us, we can see that 3 is connected to 9. I mean, 3 goes into 9. We have some pattern there, but I'm not going to establish or talk about that pattern until we actually figure out the rest of them. Hopefully for your rectangular prism, guys, you realize that you had 12 edges. And again, we've done enough rectangular prisms over the last handful of days that hopefully you can see those and you can visualize those. But remember that we have, the biggest thing with edges is we have 3 different locations. We have the top and the bottom, and obviously the number of sides that we have in a rectangle, so 4 on the top, 4 on the bottom, and then there's always the same number that connects the top to the bottom with those edges. All right, if you remember my outlining the other day, and I'll scroll up here a little farther to show you this, if this is the top, or the bottom, excuse me, 4 there, 4 there, and then 4 connecting. So it's 3 locations. 4 on the top, 4 on the bottom, and 4 in the middle. Or 4, oops, scrolling the wrong way. 4 times 3 gets us to 12. Well, let's take a look at the pentagonal prism and see if that pattern, 3 locations of the same number, is the same. Well, you're going to have 5 edges on the bottom of a pentagonal prism because a pentagon has 5 sides or 5 edges. The top is also going to be 5, so we've got 2 for sure. And then from each of those vertices, you are going to go up again with 5 more edges. So the same rule applies. We are now looking at, because it is a prism, we have 3 locations of the same number. Once we establish, again, all about the base, once we establish that base and how many sides it has, we can determine each of these categories. So the pentagon is going to have 5 times 3 or 15 edges. Same thing with the hexagon, 6 on the bottom, 6 on the top, and 6 connecting, or 6 times 3 and 18 edges. And now without the picture of the decagon, so no real way to figure it out by imagery or counting, we have to understand the pattern. Well, the pattern at this point is number of sides on the base times 3 locations, top, bottom, and middle. So 10 times 3, we should have 30 edges in a decagonal prism. Now remember, these are all prisms. We will talk about the pyramid in a very short period of time here. All right, and then the last one for prisms. We are dealing with the triangle. So now we see we go from 3, and I'm going to change colors here just for the simple fact that we can then see, because I'm kind of getting a lot of blue on the screen here. We start with a 3, and now we end up at a 6. Again, another number that goes into another. So we have a connection here. Now vertices, remember, are the corners. They are the points at which 3 faces come together, or what we consider to be the corners. And if we're looking at these ones, we can see right here, any spot where we have pointed edges, and I'm just doing on the pentagonal prism here, we've got 5 on the bottom. Remember that we only have those in 2 locations, though, on the top and the bottom. There is no vertices, there are no vertexes in the middle of these shapes. All right? So that's why we end up with then 3 to 6. Well, let's check with our rectangular prism. 4, we've got 4 vertexes on the bottom, or 4 vertices on the bottom, and 4 vertices on the top, for a total of 8. Pentagonal prism, 5 vertices on the bottom, 5 vertices on the top, for a total of 10. So now, instead of multiplying by 3 locations, for vertices, we only have 2 locations, a top and a bottom. So again, understanding how many bases you have. In a prism, we have 2 bases, a top and a bottom. And so that's where our 2 locations come in. Hexagonal prism then gets us to 12 vertices. And again, even without the image now, the decagon should be relatively easy. 10 vertices on the bottom, 10 vertices on the top. 10 plus 10, or 10 times 2, gets us to 20. Okay, so that's a pretty easy math pattern, or establishing of a formula, so to speak, that helps us understand how many of these things we have. Now, I don't expect you to be perfect experts at that right now, but hopefully that will, the more we continue to practice these skills, guys, the more that will become consistent or easier for you to understand. All right. Now, obviously, it has to be a slightly different idea when we're dealing with pyramids. Okay? So here we are looking at a triangular pyramid, a square pyramid, a pentagonal pyramid, and a hexagonal pyramid. Okay, I'm going to do the first couple with you. They obviously do the triangular pyramid with you. I'm going to do the rectangular and the pentagonal, and then your job is going to be to answer the hexagonal and the octagonal at the end of this video. All right, so the triangular pyramid, again, triangles have 3 sides. So we are looking at the triangular pyramid right here, 1, 2, and 3. It has only 4 faces. Now, the reason it is not 2 more is, remember that our top doesn't have a base or a face, so to speak. It goes right to a point. So in the idea of a pyramid, we have 1 base plus the number of sides. Okay, so in this case, 1 base plus 3 sides gets us to 4 faces. Number of edges, again, has to be a different pattern here. We don't have 3 locations for our edges because we go to a point at the top. So we only have the number of sides on the base, or the number of edges on a base, and then the number of edges going up from that base to our point, to our vertex at the top. So in this case, it is 3 times 2 for the number of edges gets us to the number 6. And then the number of vertices is however many vertices we have on the base, 1, 2, and 3, plus the one vertex at the top. So always going to be the number of sides or number of points on the base plus 1 for our pyramids. All right, so let's try that same concept with our square pyramid then. Obviously, squares have 4 sides, and this could be considered the same with a rectangular pyramid. Number of faces. Well, we've got 1 for the base here. Because it is a 4-sided figure, there's 1 face going up from each of those sides. So 4 plus 1 gets us to 5 faces. Number of edges going up. Now, instead of having 3 locations, a top, a bottom, and a middle for our edges like we did with our prisms, with our pyramids we only have 2 locations, the bottom and the middle going to the top point. So in this case it is 4 times 2 or 8 edges. And something easier about the pyramid, guys, is that the number of faces always matches the number of vertices. And I don't know if you noticed that on the first one, that the 4 and the 4 were the same. Well, it's the same thing here. We've got vertice 1, 2, 3, 4, and then the 1 at the top for 5. And so again, it matches up. These 2 and these 2 are matching up with one another. All right, let's check one more just to prove our pattern. I'm going to change colors just so we can see the difference here. We'll try the pentagonal pyramid, and then your job, guys, on an exit ticket will be to answer the hexagonal and the octagonal pyramid patterns, okay, or numbers for those 3 categories. All right, so pentagonal pyramid. Pentagons have 5 sides. We got 1, 2, 3, 4, and 5. Let me shrink the size of my ink here just so we can go that way. So we are looking at a 5 here in pentagonal sides on a base. Number of faces. Well, we've got 1 bottom and 5 faces going up from those bottoms for a total of 6. So again, just like before, plus 1, plus 1, plus 1, not minus 1, sorry, plus 1. All right. Now, number of edges. In the first 2, we had the pattern of doubling it. Okay, 3 sides in a triangle. Number of edges went up by doubling. Rectangular has 4 sides. Number of edges went up by doubling. Let's try to see the pentagonal. Number of edges. Well, we have 5 edges on the bottom. 1, 2, 3, 4, and 5. And we've got edges going up from each of those vertexes to the top vertex. So we've got 5 on the bottom and 5 on the sides for doubling to get us to a 10. And lastly, we'll see if the same pattern continues with the number of faces and the number of vertices being equal. Well, we've got 5 vertices. Change colors again just to give us an idea. 1, 2, 3, 4, 5 vertices, and 1 on the top for a 6 vertice shape. All right. Thank you guys for paying attention. Hopefully you are starting to see the differences between our prisms and our pyramids. This will be the last day on that. Tomorrow we will start working on something called a net, and we'll start working on surface area. Have a good day. Make sure to answer your exit ticket, please.